All right, let's do some examples so that you know what to do when we're working these problems out. Let's start with this first one. Comes from number 1. In order to multiply this, we're going to distribute this 3. 3 times 10, 30. 3 times 4, 12. It'd be add because it's a positive 12. We could then combine terms that are alike. 30 plus 12 is 42. I know that you could have gotten the same answer by adding the 10 plus the 4 and multiplied 3 times 14, but this is to help you understand what to do and how to distribute. In this case, you can't combine the a plus the b together to make an ab, so you have to distribute the 3. 3 times a, 3 times b, 3b. Again, it's going to add because it's a positive 3b. This is the basic idea of the distributive property, or as your book calls it, the distributive law. Let's take a look at this next one here. Now we have two variables, x times a. Now you may want to go xa, but normally we're going to put this in alphabetic order. So we're going to call it ax, then the x times the 3, 3x. Now what do you do when you have the same variable but it's being multiplied? Right here, when we go x times 3x squared, an important thing to remember is this. An x squared is essentially x times x. And x to the first power, no variable, is just 1x. So if I take an x and I multiply it times an x squared, what you're actually going to do is you're going to have this x and then your x squared. And so you get this answer because there's 3 of them all together, x to the third power. The shortcut to that then becomes, when you have the same base, you can add the exponents. 1 plus 2 is 3. So x times 3x squared would be 3x to the third power. X times x would be x squared, not 2x. We're not adding them. We're multiplying. Then x times 1 is just x. Two more examples here to know what to do when you get to two sets of parentheses. Now in this first case, you could do the 2 plus 3 and distribute a 5. But just so you can see how the distributive property works, let's do it this way. We're going to distribute the 2 first to both of these. 2 times x, 2x. 2 times y, 2y. But now we need to distribute the 3. The 3 also gets distributed to both in this next set of parentheses. 3 times x, 3x, 3 times y, 3y. We can now combine like terms. In this case, there's two sets of like terms. The 2x and the 3x are like terms, so that becomes 5x. The 2y and the 3y, 5y. Now, the most important one, and the one that you'll see most often, looks like this. But let's follow the same pattern. X times x, x squared, right? The x times this x, they're both to the first power, x squared. X times 2 is 2x. Now we're going to distribute the 1. 1 times x, 1x. Notice we don't have to write the 1. 1 times 2, 2. Now we're going to combine our terms that are alike. And notice we have two terms that are alike. The x squared can't be combined with these, but the two x's can be combined. I have an x squared. There's two x's. There's one more x here. Since I'm adding, this is not the same thing as multiplying. Two x's plus another x. I have 3 altogether. And then my plus 2 at the end. So that's the basic idea of what you're doing with these. Hopefully this helps you. Let me know if you have any questions.